So our next speaker is Otto, who will also be talking about Schizocosa ocreata, but rather their compensation during courtship by upregulating or downregulating the vigor of their courtship. So do you have your, yes.
All right, thank you. So my name is Otto, and I'm also a student in the UTS lab. I work with Olivia and Dr. Utz. So before I begin, I'd like to thank them for their contributions to this project. They've brought amazing guidance and contributions, so thank you to them. I'm going to talk about my experiment with the brush-legged wolf spider, and my title suggests that they may be able to use behavior. The males may be able to use behavior during courtship in order to compensate for a physical trait that indicates poor condition. So when it comes to courtship and mating, spiders are an interesting case because they have to face potential cannibalism from females. When the males are courting, they're going to produce signals that provide information about species identity and condition. That is what's going to be able to pacify potential females and persuade them to mate. Female mate choice is often based on male traits during courtship, such as leg decorations, such as the tufts on our study species, or courtship vigor. So an introduction to the brush-legged wolf spider, which you guys already have seen in Olivia's presentation, but just a recap. This species gets its name from the conspicuous tufts that you can see on the forelegs of adult males, and that trait is only going to be seen in adult males. So this species is sexually dimorphic, with the males being smaller than females and also having these tufts. And the tufts are a courtship aid and are used during the visual part of courtship. As Olivia said, this species uses multimodal courtship, so they use both visual and vibratory signals in their courtship. Previous studies have shown that female receptivity is at its highest when both visual and vibratory signals are in place during courtship. However, females will sometimes also show receptivity to visual or vibratory communication alone, with females showing higher receptivity when with visual alone compared to vibratory alone. This species is common in the eastern US deciduous forest leaf litter. The leaf litter provides a substrate for the vibratory signals to travel across and also provides places to hide from predators. So this is about male tuft size, courtship vigor, and how that reflects their mating success and their probability for mating. As you can see on the graph to the left here, tuft size is positively correlated with female receptivity. So the larger tufts that a male has, the more likely that they're going to be successful in mating, and the higher fitness and reproductive success they're likely to have. The graph on the right shows the rates of jerky tapping and its relation to receptivity. So jerky tapping is a male behavior that is done in courtship, and we use it as a proxy for courtship vigor. So the higher the rate of jerky tapping, the greater the courtship vigor the individual has. And this graph shows that courtship vigor and jerky tapping are also positively correlated with receptivity. So males with higher courtship vigor, they're doing more of these courtship behaviors in a certain amount of time, are going to also be more successful in mating. So as Olivia stated, male foreleg tufts are fixed at adulthood, and they're a condition indicating trait, and they indicate that individuals have been successful in foraging in the past. So once you're an adult male, your tuft size cannot be changed. So if you're a small tufted male, what possible avenues do you have, or do you have any possible avenues for compensating for a smaller tuft size in order to raise your reproductive success or raise your probability of mating to be on par, or to kick it up a notch to be kind of level with the rest of the members of the population? That is the question that led us to develop the courtship compensation hypothesis. which is asking, can males with lower tuft size below the population mean compensate for that trait that is less than desirable by influencing their courtship behavior? So tuft size is a static trait. They can't really do anything to influence that. However, behavior is a more plastic trait. They can influence their courtship vigor depending on how much energy they want to put into it. And so that's going to be a better avenue for trying to compensate for these traits and increase their reproductive success. Tuft size is a trait that is variable within populations of this species. And as you can see on the graph to the left here, it follows a standard curve. So the variability in tuft size is what allows for sexual selection to occur for this trait. And if females are more likely to be mating with males with the larger tufts, that is going to influence future populations and the genetics of the population as a whole. So this is the same graph that was shown a few slides back, showing that tuft size is positively correlated with female receptivity, but this one is showing a few more details, which is related to the video exemplars that we use for video playback. So female receptivity to male courtship can be seen both in live trials with live males and in video playback of male courtship, in which we show them a video of a courting male and they will show receptivity to that as well. So for these videos, we can manipulate traits such as tuft size and courtship vigor. And this is showing how those manipulated or how those traits influence just how much of a difference it makes for those traits in receptivity. So the one on the left here with -T is reduced tuft size, and it's the 5th percentile tuft size. So the one in the middle is the mean tuft size, and the one on the right is increased tuft size, which is the 95th percentile tuft size. And the reason that we did it this way is so that they will be at the extremes of the trait that is in the population, but still within a natural range for what may be seen in the wild for tuft size. And they did the same thing with courtship vigor here. The 5th, mean, and 95th percentile of courtship vigor was altered in the video exemplars and used in trials. And you can see how much of a difference it made for the low vigor, mean vigor, and increased vigor when it comes to jerky tapping, which is, again, a proxy for courtship vigor. Excuse me 1 second. Okay, so these are examples of video playback that can be used in the trials. The first one is just your average male, average tuft size, average vigor. The second one is the 5th percentile of tuft size with average vigor. And the last one down here, I'm not sure if it's going to play, but if it does, is reduced tuft size, increased vigor. So with the courtship compensation hypothesis, what we want to see is if the one with reduced tuft size and increased vigor is able to bring that receptivity up to be equal or about equal to the average male. And if that is true, and then there is no difference between those two individuals, that would mean that the courtship compensation hypothesis is supported and the playing field has been leveled using courtship vigor. And that is kind of what we can see here between all three groups, all three treatment groups. There was no statistically significant difference. We used a one-way ANOVA test to show the differences between the three groups. And you can see that the average male on the right was not significantly different between the other two groups, reduced tufts, increased vigor, reduced tufts, average vigor. So that would mean that the courtship compensation hypothesis is supported, even though that there is a trend for the one to be a little bit higher. So these are the results of a previous study showing the intersection between tuft size and courtship vigor in relation to female receptivity. As you can see in the middle column here, if you have average tuft size, then the female receptivity score is going to increase statistically significantly whether you have low courtship vigor or high courtship vigor. And if you have average vigor, then tuft size is going to influence receptivity. Higher tuft size in this case is going to increase receptivity. However, if you look at the bottom row of increased vigor, tuft size does not seem to matter when it comes to receptivity. All three tuft size show about the same high receptivity. And in the bottom left circled category here with the reduced tuft size, increased vigor, which is one of the groups that I was testing in my experiment to see if it was equal to the average male, you can see that that individual, even though it has reduced tuft size, has equal or higher receptivity than any of the average or increased tuft sizes males. So that provides more support for the courtship compensation hypothesis. So what does that mean if the courtship compensation hypothesis is supported? Well, courtship compensation would be an example of deceptive signaling. So males can hide their poor condition by increasing their courtship vigor and persuading females to mate and combating the effects of sexual selection for larger tufts. And what that may do is prevent smaller tufted males being eliminated from the population through sexual selection, which would help maintain tuft size diversity. Another thing that it could mean is that these males are able to level the playing field and make their mating success equal, which would make tuft size less of an indicator of a male's reproductive success. And reproductive success would be increased by courtship vigor. So for my acknowledgements, I'd again like to thank Dr. Utz and Olivia Bauer-Nielsen, but I'd like to thank the other undergrads in our lab for helping take care of the spiders and collect spiders. I'd like to thank Cincinnati Nature Center for allowing us to collect spiders there, and the university for helping us do the work that we do. And I'm ready for questions.
Yay. Sorry, you can't hear the audience clapping, but I'm sure they all are. All right, so can tufts become so large that they become disadvantageous, like extra large tufts outside the natural upper end of the range?
So I'm not sure if they could be. One thing that is a disadvantage for larger tufts is that it also makes males more conspicuous to possible predators, such as like other spiders or frogs. So there is kind of like a disadvantage there, similarly to, you know, how peacocks or certain birds, they're more brightly colored, they're more attractive to females, but they're also more attractive to predators. It's kind of the same thing here. So it is somewhat of a disadvantage, but it seems that the sexual selection is more important than the disadvantage that they have from being more attractive to predators.
So a female will never say, oh no, that's too big.
No.
Okay. All righty. So what percentage of the population has smaller versus regular versus larger tufts?
So it does follow like a more like normal distribution. So most of them would have like more tufts that are more in the middle and sort of smaller or larger. So I would say it's a pretty even distribution, with more being in the middle.
Cool. So does the color contrast of the tufts compared to the rest of the male play a role?
I would say it probably does. I might have to look into that a little bit more. Maybe Olivia could take a crack at that, but I'm just saying that, you know, tufts are an important role in visual communication, and spiders have, you know, very good eyesight, so they can able to see like small differences, you know, because if you have, you know, smaller tuft size, you know, the 5th percentile to the mean to the 95th percentile, that's not a really huge difference, to be honest. Like if you were to look at it yourself as a human, you might not even really notice it that much, and the spiders can notice those like small minute differences. So I'm sure that like the color contrast does play a role there. All
right, and there's a final question. Do Do you see compensation in live males?
I did not test live males for compensation, but that could be a possible future avenue. I know that another student in our lab, Brielle Robbins, she did another study that was similar to this, showing to see if males could assess their quality themselves when it comes to tuft size, and she used live specimens. So that is another thing that we've been looking into.
Right. There's a couple more questions, but I will have to leave them there, and so we can move on to our next speaker. But very good job. Thank you so much.
Thank you.